In this video lesson, we're going to learn how to draw Lewis dot diagrams using a method called the valence electron bank. So there's many ways you can solve a Lewis dot diagram question or to draw a Lewis structure, but I'm going to show you how to use the valence electron bank, which is a method that I really like. It does involve a little bit of trial and error. So for example, I'm going to show you how to do this one, HNO2. This, by the way, this question comes from one of the older AP chemistry exams. And we're going to solve it together, but I'm just going to show you it's a little bit of trial and error using this method. So for example, if I've never seen this compound before and I had no idea how to bond these atoms together or how many lone pairs that each element would have, this electron bank will hopefully just kind of help me visualize it. Okay, how does this bank work? We're going to take each element. So let's start with hydrogen. And we're going to write down how many valence electrons it has. So hydrogen has 1, oxygen has 6, but there's 2 oxygens in the formula, so we're going to say 12 valence electrons total, and nitrogen has 5 valence electrons. And what we're going to do is we're going to add all these up, and we're going to have our total valence electron bank of 12 plus 1 plus 5, 18 valence electrons available to work with that we need to empty to 0. So when I empty my valence electron bank, because the skeleton of the diagram is already given to me, I'm going to start by putting in bonds. And because I'm not sure if this compound has single bonds or double bonds, I'm going to try single bonds first. Okay, and actually this is the wrong answer, but I'm just going to try this first to see why it's wrong, and then we'll fix it after. Okay, remember that each bond is 2 electrons. So by putting these 3 bonds in, I have emptied 6 valence electrons. So that brings me down to 12. Okay, now what that means is I need to put exactly 12 lone electron dots around the elements. Remember that hydrogen is already maximized. It can only take 2, and there's already 2 electrons around it in the bond. So we'll go over to the oxygen here. Actually, sorry, let me make that a little clearer. So we'll go over to the oxygen and we will give oxygen is 2, so it needs 6 more electrons around it to get 8. Nitrogen will need 4, and oxygen will need 4. Now, here's the thing though, this is the wrong answer because if I add up all the lone electrons I've used, I have 4 plus 4 plus 6, so I've actually used 14 lone electrons, and I don't have 14. If you look in my bank, I actually only have 12 left. So this is wrong, and we're going to start again. Now, how do you, I guess, tackle this if it's wrong? So let's go back to initially what we had. So let's start over here, okay? We have 18 electrons in the bank. Okay, well, what I'm going to do, knowing that all single bonds didn't work, I'm going to include a double bond now between nitrogen and oxygen. Now, how did I know to put it there? Well, there is another check we can do later called the formal charge check. Formal charge. And I don't know if I'm going to do that now just because to save time in the video, but I'm going to put that double bond there as it will fulfill this formal charge check, which we can look at in another video if you're interested. Okay, now guys, by putting in 4 bonds, I've emptied 8 valence electrons, so I'm left with 10 valence electrons that I need to empty. So I'm going to put the rest as lone pairs or lone electron dots. So if we go over to the oxygen on the right, there's already 4, okay, because of the bonds. So we're going to put 2 pairs here. So that's 4 valence electrons total. Sorry, that's not clear. Let's fix that up. Okay, now for the nitrogen, there's 6 electrons around it, so it just needs 1 pair. So I'll put that at the top. And then the oxygen on the left has 4 electrons around it because of the 2 bonds. So it will need 4 electrons or 2 pairs. So now if I count up my lone pairs, I've got 4, 5, 6, 7, 8, 9, 10. That actually empties my electron bank to 0. This is what I want. So I know this is the correct answer. And again, I know it's the correct answer. I had to put the double bond here as that satisfies the formal charge check, the formal charge rule, better than putting the double bond beside the other oxygen. Okay, so hopefully that makes sense. Let's try another one from an older AP exam. So in this question, again, I'm given the skeleton of HCOOH, and we're going to complete the diagram by drawing all the bonds as well as the non-bonding lone pairs. Okay, so let's set up an electron bank. hydrogen, 1 valence electron times 2. Okay, there's 2 of them in the formula. If you're not sure how I'm getting the valence electrons, please ask in the questions or in the comments. Carbon has 4 valence electrons, and then oxygen has 6, but we have to times 2 again because there's 2 of them in the formula. So if you add up this bank, I have, again, 18 valence electrons to empty. So let's see if I can do this a little quicker this time. So we empty the bank first by putting in bonds. Now, oxygen and hydrogen here, this can only ever be a single bond, okay, because hydrogen, remember, can only take 2 electrons. Same thing here, that could only ever be a single bond. So if I do that, and then if I bond this carbon and oxygen and this carbon and oxygen, I've emptied 8. Actually, I'll just write it down so we can visualize. So that means I would have 10 electrons left to put as lone pairs. Okay, well, hydrogen cannot take any. Carbon would need a lone pair there. Oxygen would need 2 lone pairs. And the oxygen at the top would need 3 lone pairs. Okay, to get these stable octets. And yes, by the way, some elements can exceed an octet, so that there are exceptions to the octet rule, which I'm sure you've talked about in class. I'm sure that you'll see other examples of that as well, but that doesn't apply to this question. Okay, guys, by doing that, 2, 4, 6, 8, 10, 12, I've used my lone pairs. I've used 12 valence electrons, and I don't have 12, so again, I know this is wrong. So let's erase all of this and kind of start from scratch. Okay, so this hydrogen and carbon, that must be a single bond. There's no other choice there. Same thing with this one. Now, because all single bonds didn't work, I'm going to try a double bond now here between carbon and oxygen on the top. And again, we can verify what's the best structure using formal charges, but we'll do that maybe in a separate video. By doing this double bond on the top, I've now emptied 2, 4, 6, 8, 10. I've actually emptied 10 valence electrons because I've used 5 bonds. So I've got 8 valence electrons left. So carbon actually cannot have any lone pairs because if you look at it carefully, it already has an octet or 8. But the oxygen on top is going to need 2 lone pairs, okay, to get 8 electrons total. And the other oxygen will also need 2 lone pairs to satisfy its octet rule. And if you look carefully, I've used 8 dots to empty the bank, I've used 8 dots to put as lone pairs to make oxygen stable, which has helped me empty the bank. So now that the bank is emptied, I know that this is the correct structure. And again, I could verify my answer with a formal charge check, which we can maybe do next time. Okay, let's do one more. Okay, this is from, again, one of the older AP chemistry exams. We have S2Cl2. And again, we have to just fill in the skeleton diagram by putting in bonds and lone pairs. So my electron bank is like this. Sulfur has 6 electrons, valence electrons, but there's 2 of them. So we're going to say 12. The chlorine has 7 valence electrons, but again, there's 2 of them. So we're going to say 14. Now so we're going to add this up. I like to do this first by putting in single bonds. Okay, so we empty the bank first by putting in single bonds. So I wouldn't suggest putting double bonds right away because we don't know if that's going to need a double bond. So start with a single bond, and then if it doesn't work, like I showed you before, then you could go back and fix. So let's put single bonds between all of these atoms, and that will empty 6 valence electrons from the bank, leaving me with 20 left. So those 20 valence electrons, let me make this a little thicker so I can see the dots better, but let's empty the electrons as lone pairs. So chlorine, it needs 6, okay? Also this chlorine as well, it needs 6, because remember, we're going for an octet, so that I've emptied 12. So I'm left with 8. And for the sulfur will also take octet in this question. And as you can see, by putting those lone electrons there and plus its bonds, that gives it 8 electrons. That empties 8 valence electrons. Okay, this is a little messy, but hopefully you can see what I'm doing. That empties my bank to 0. I could also, I'm kind of mentally checking the formal charges. I know that this is the best structure for S2Cl2. Okay, I hope that helps. I hope you like the valence electron bank method, and please feel free to ask any questions you have in the comments. Thank you very much.